Good morning. Welcome to my tutor. Today we're going to start short videos on topical questions. We're going to start with graph transformation, a new topic that started in AS Mathematics 9709. That is graph transformation. A lot of students are caught off guard, as well as a lot of tutors and lecturers which are not prepared, especially in this pandemic time. So let's go. The graph of y equals fx is transformed to the graph of y equals to 1 plus f half x. Describe fully the two single transformations which have been combined to give the resulting transformation. So in this question, you need to know the symbols of how graph transformation is reflected in function notation. Now, there are two transformations in this question, which is a stretch and a translation. Okay, whenever you describe combined transformation, you have always to describe a stretch first, because a stretch will always be with invariant line x or y axis, or vertical or horizontal stretch. So in f half x, this is a horizontal stretch. Stretch scale factor. If it's 1/2, then the scale factor is 2. And invariant line, always horizontal stretch, invariant line is always the y-axis. Okay. Okay. Now the plus one would be a vertical translation of plus one. Okay. That's the answer. Second question. Functions f and g are such that fx equals to 2 minus 3 sine 2x. Gx equals to minus 2fx. State the ranges of f and g. So here we have trigonometrical functions. So in your admits in IGCSE, you would have learned about the period on sketching of graphs. So if you look at this function, the graph of fx, I will try and sketch. 2 minus 3 sine 2x. So basically, what I will do is I will first sketch the shape of the graph. Okay. So the shape of the graph is a reflection on the x-axis. So the graph will be a reflection on the x-axis. So it will be going down first and then going up, coming back down. So this is a graph where it is a horizontal stretch by a scale factor of half. So you have one period in terms of 0 to pi, okay? And a vertical translation of 2. So this will be the x-axis. This will be y-axis. This is 2. So the stretch, vertical stretch is 3, or the amplitude is 3. So this will be minus 1. Here is 5. So if you look at this graph, the range of fx will be between the minimum value of -1 and the maximum value of 5. Okay. Now gx is minus 2. fx. So you will have a stretch 2 times with a reflection on the x-axis. So if you write gx minus 2fx, it will be 6 sine 2x minus 4. Okay. So basically you will have just a function that goes between, if you look at fx, it's 2 times. So gx will be between minus 2 and 10. Okay, so if you want to draw the graph, you can draw the graph as well. Oops, forgot. Sketch the graph first. So this is the graph, which goes down. Oops, I think my values are wrong. Luckily, I checked. So the graph will be a vertical translation of minus 4 with a stretch of 6. I forgot it's a reflection, so it's this will be 2. This will be minus 10. This minus 4. So it's between minus 10 and 2. I forgot the reflection. Okay, so sometimes it's good to sketch the graph. The diagram below shows the graph of y equals to fx. This is y equals to fx. Oh, okay, which I've drawn. Sketch on this diagram, the function h is such that hx equals to gx plus, y equals to gx. Just now I sketch gx for you already. So gx is basically a reflection and then a stretch by 2. So this is gx. Okay. Function h is such that h equals gx plus pi or minus pi to 0. So this gx plus pi, again, the function notation of a graph transformation. Gx plus pi will be a horizontal translation by minus pi. So if you have from fx to gx, again, first you need to describe your stretch first. So first it is it's 2 fx. Okay. So it's a vertical stretch scale factor invariant line x-axis. Number 2, reflection on the x-axis. Number 3, horizontal translation, which is what is been described in hx by negative pi. There we have it. So this lesson will encompasses graph transformation. So if you want to know more about graph transformation, subscribe to this channel. We will have more short videos on graph transformation. Bye for now.